All right. Good morning, chemistry class, Yolis and Leilani. I hope you guys had a good week last week, and I hope that the lesson wasn't too confusing. Hopefully, it was just some review, and it was good. Hopefully the review questions. So this video, we're going to go over the review questions on the unit defining the atom, and then the next video will be a new lesson of different stuff. But these are the questions that hopefully you guys answered on your own time. All right, here we go. Hopefully they weren't too hard. So, yes. So, I don't, whoever wrote these questions wrote them like out of order. And so they didn't start at number 1, they started at number 7. But I don't know what's going on with that. So number 7, describe the structure of a typical atom. Identify where each subatomic particle is located. Okay? I think this should be pretty easy, hopefully. So you have an atom, right? I'm not the best artist, but basically, if you were to identify where things are located, you have the nucleus, right? And in the nucleus, what's there? That's right. I heard you. Protons and neutrons, okay? So I'm going to draw, here's a proton, here's a neutron. This isn't, I'm not enough for my art skills. But essentially, proton and neutron are in the center. So then what else do we have? We have electrons. And where are the electrons? Well, we don't know. They could be anywhere else in the atom. So you could have a little electron up here, one here, one here, one here. Okay? So those are the 3 basic subatomic particles we learned about in the last lesson. And so this is where they're located. This is the center. This would be the nucleus. Right? And remember, over 99% of the mass of the atom is located here in the center, at the nucleus. Okay? So you have that, protons, neutrons, electrons are everywhere else. And they're spread out in the rest of the space of the atom. Okay? Our next question. Sorry, I'm walking off the screen. Compare and contrast Thomson's plum pudding model. Remember, that was like Tembleque? Thomson's plum pudding model with Rutherford's nuclear atom model. Okay? So what were the big differences? Do you guys remember? So I'll try to get you refreshed. So the plum pudding model was only electrons, only negative particles. And he didn't know about the nucleus. Okay? So here's Thomson. Plum pudding, it's like pieces of coconut and Tembleque. Here we are. Lots of pieces of coconut or plums in the pudding. However you want to call it, okay? But, you see, he didn't know there was anything in the center. He just said the atom has lots of electrons and they're all floating around. Okay? That's what Thomson said. And the Rutherford was the gold foil experiment where they shot and they bounced back. He shot the positively charged alpha particles of the gold foil, and some of them would hit the nucleus and bounce back. So then Rutherford said, oh, there's a positively charged nucleus at the center. But he didn't know about neutrons, okay? So the only difference is Rutherford has the nucleus at the center that's positive. And then the electrons are still around the outside, okay? So just compare and contrast. I mean, there's not a whole lot there to compare and contrast. You would just say, the similarities, they both had electrons, but the difference was Rutherford's model had a nucleus that was positively charged. It didn't have neutrons, just a positively charged proton. He didn't really know. He just said a positively charged nucleus. Okay? That's how we compare and contrast those. All right? Here we go. We'll come over here. Sorry, I know I'm kind of awkward, but hopefully so far you guys got both of those right, based off of looking at the PowerPoint on mine. I didn't hear any comments from you guys, just if you were confused or not. But if you're confused, let me know. Or if you, hopefully you had time to do the questions. Because, doing questions is how you reinforce your learning. All right, number 9. Evaluate the experiments that led to the conclusion that electrons are negatively charged particles found in all matter. Okay? You guys remember this? There was like kind of one experiment, and there was other ones they didn't really mention. They just said other experiments happened. But basically, it was the cathode ray experiment. You guys remember this? Cathode rays are what old school TVs are made out of, if you remember me talking about that last week. So the cathode ray experiment, a cathode ray is where there's like this ray tube. I did a better drawing this week, see. There's a ray tube that's negatively charged on one side and positively charged on the other. Okay? This is the cation, or cation, however people say it different. It's the anion, okay? And the charge flows from negative, the cation, to positive, the anion, okay? But for our purposes, all you need to know is that they passed electricity through it, and they were like, whoa, the particles flow from negative to positive, there must be negative particles. And then they did different experiments. They did different experiments where you could, they changed the variables. They tried different metals, they tried different levels of charge, and no matter what, there always was electrons. They're like, look, electrons must be in all matter. So it was the conclusion was that, the conclusion that electrons are found in all matter, but the experiments they did were with the cathode ray. They did the cathode ray experiments, and they changed the variables, different metals, different charges, but there were always electrons. So then they said, okay, electrons must be in all matter, everything, okay? I think that could be a little confusing, but basically it was just, they passed electricity through a tube, and they changed variables, and there were always electrons. So then they were like, well, electrons must be in everything, okay? Then we have our last question. Oop, can't get this thing. Man, I'm just not good at this YouTube thing. I'm sorry. I wish we had class. Okay. Compare the relative charge and mass of each of the subatomic particles. Okay? So this don't worry. This table was in your guys' PowerPoint, but you don't need to worry. The main thing from this you need to understand is the different charges and how big protons and neutrons are compared to electrons. That's all you need to know. You don't need to memorize these numbers, or even if you didn't write them down, it's okay. Okay? So here, electrons have a charge of -1, right? I'm sure you guys remember that, hopefully. Protons are +1, and then neutrons have no charge. They're neutral, zero, like my bank account is neutral, 0, all right? No money, no hay chavo. So as far as electrons go, so relative mass means, so these are both 1 for relative mass. These are the basis of the relative mass. And the relative mass of the electron, hang with me, is 1 over 1,840. You guys see that? 1 over 1,840. Which means if you were to break a proton into 1,840 different parts, an electron is only the same size, same weight, same mass as one of those parts. So basically this is, it's 1,840th of a proton. So you break the proton into 1,840 pieces. The electron is only the same mass as one of those pieces. So it's way smaller. That's all you need to know. So if these are both 1 on the relative, it's all relative. So compared, proton is like here, or the protons here as far as size, electron is like way down there. Way smaller, okay? That's all you need to know. Electrons are way smaller than protons and neutrons. And then you have the actual mass, which are just numbers. And you guys probably learned about scientific notation. I think Yoli Elliott's got scientific notation pretty good. But these are both basically the same, 1.67 times 10 to the minus 24th. Right? But this is 9.11 times 10 to the minus 28, and that is way smaller in grams. And those are tiny, tiny numbers, right? And you guys know, we can't look and see electrons and protons and neutrons on our hand. You can't see them. They're not there. They are there, but you can't see them with our eyes. Our eyes can't see them, okay? So that's all you need to know. They're very small. An electron is the smallest one. It's way smaller than protons and neutrons, but they're all very small. Okay? There we go. That was the last question. Is just some calculations, and frankly, like math is important, but I'm sure Mr. Lopez is working you guys really hard in math class. So we'll just not worry about that because it's gonna just be probably confusing, and we'll just go on to the next lesson. Okay. So I'll see you guys later this week for the next lesson. All right. Remember, chemistry is fun. I know. I wish we had class. Hopefully, yeah. We'll see. I'm gonna keep making these videos, and hopefully they help a little bit. And hopefully, since I'm not, I'm assigning homework, but I'm not planning on doing exams or anything because you guys are so busy with other stuff, and I don't really know how to give an online exam. But let me know if you have comments, if I'm too confusing, if I'm talking too fast. Yeah, let me know. But yeah, all right, chemistry's cool. See you guys next time.